Very good morning to one and all. I am Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering, MLR Institute of Technology. Today, in this lecture, we are going to give a brief about the course Aerospace Propulsion 1. Let's enter into the course introduction. So, let's first discuss about what is aerospace propulsion. What is aerospace propulsion? First, it has divided into two words, aerospace and propulsion. And aerospace is nothing but the combination of air and space. It is a combination of air and space. So it is called as aerospace. Next, coming to the word propulsion. The propulsion deals with propelling of bodies. Propulsion deals with propelling of bodies. So what is propelling here? Propelling means giving motion or pushing to bodies. Propelling means giving motion or pushing bodies. Okay, so finally, the propulsion deals with action of motion or pushing. Okay, propulsion deals with propelling of bodies. That means propulsion deals with action of motion or pushing. So finally, combining these two, aerospace and propulsion, finally we can say aerospace propulsion deals with concept of giving motion to bodies in air and space. In air in the sense in our earth atmosphere, space means outer atmosphere. So aerospace propulsion deals with concept of giving motion to bodies in air and space. It deals with propulsion systems, that means engines, which helps to move in air and space. So overall, we can say aerospace propulsion deals with the engines. It deals with the engines, that means propulsion systems, which helps to move in air and space. Next, coming to the course objectives. The first objective is to understand the application of various experimental fluid mechanics, thermodynamic correlations in propulsion. To understand the application of various experimental fluid mechanics and thermodynamic correlations in propulsion. This is your first course objective. Here, fluid in the sense we deal with the air, thermodynamics means we deal with the energy, heat energy. So how this combination of air and heat energy relates to the propulsion that we are going to learn in this course. So this is the first objective, and the second objective to understand the basic concepts of compressible fluid flow. You might have gone through the different types of fluid flows like compressible and incompressible fluid flows in aerodynamics. Here, in coming to the propulsion, we deal with the compressible fluid flows. So in this, we are going to understand the basic concepts of compressible fluid flow. Next, coming to the course outcomes. So what you are going to get after completion of this course. You can analyze principle of various engines and thermodynamic cycles. You can analyze the characteristics and performance of various types of jet engines. You can examine the various types of inlets and principle of axial flow compressor. You can evaluate the performance of combustion chamber. You can analyze the characteristics of turbine and nozzle. These are the course outcomes. Next, coming to the syllabus. First unit, unit 1, fundamentals of gas turbine. Unit 1 is fundamentals of gas turbine. Unit 2, air breathing engines for aeroplanes. And Unit 3, inlets and compressors. Unit 4, combustion chamber, burners and its performance. Unit 5 deals with turbines and nozzles. See here, this is the diagram, one example diagram of a jet engine. So in the first unit 1 and unit 2, you are going to learn about the fundamentals of gas turbine and different types of jet engines. See, this is one jet engine. Okay, fundamentals of gas turbine in the sense, what is gas turbine engine and what are its parts? See, here you can able to see the parts: air inlet, compressor, combustion chamber, turbine and exhaust. This total part is called exhaust, and this part is, see here the brackets are separating the parts. This part is turbine and this part is combustion chamber. This is combustion chamber and this is also one more combustion chamber, and compressor. These are the blades. You can able to see here the number of blades here. So this portion is called as compressor and this one is inlet. So these are, here you can able to see the blue lines. That means these blue lines indicating the air. Air is entering like this from the intake and it is going to going through the compressor. After that it enters into the combustion chamber. After that it enters into turbines and it will leave the engine through exhaust. So these are the major parts in jet engine. So you are going to learn about the fundamentals of jet engines, gas turbine engines, and different types of gas turbine engines in unit 1 and unit 2. In coming to the unit 3, unit 4 and unit 5, see here we have categorized this into different parts, right? Unit 2, unit 3 deals with the inlets and compressor. See, the first one is inlet and the next one is compressor. So in unit 3 you are going to learn about these first two parts in the jet engine, inlet and compressor, that you are going to learn in unit 3. And next, see unit 4, combustion chamber, burners and its performance. The next part after compressor is combustion chamber. So in unit 4 you are going to learn about combustion chamber and its working, performance, everything. Next, unit 5, you are going to deal with turbines and nozzle. See, after combustion chamber, the next two parts are turbine and exhaust nozzle. This is exhaust nozzle. So in unit 5, you are going to learn about turbines and nozzle. So you can, that means you can understand here. In unit 1, you are going to discuss about all the parts, and in unit 2, you will get you are going to learn about the different types of jet engines. In unit 3, you are going in depth to learn about each and every part in a jet engine: inlet, compressor, combustion chamber, turbine, and exhaust. These are all included in Unit 3, Unit 4, and Unit 5 in very detail. Let's come to the contents in the Unit 1, Unit 2, Unit 3, Unit 4, and Unit 5. First, Unit 1, Fundamentals of Gas Turbine. Contents are engine types, introduction to IC engines, types of reciprocating engines, SI and CI. SI means spark ignition, CI means compression ignition. Piston engine thermodynamic cycles, piston rings, crankcase ring, rotation mechanisms. Types of air breathing engines, working of gas turbine engine, thermodynamic cycle of industrial gas turbines, types, advantages, disadvantages, and applications to industry based. Aerospace, thrust, TSFC, SFC, mass flow rate. TSFC means thrust specific fuel consumption, SFC means specific fuel consumption. You will know all the details when we discuss the topics. Okay, and the next topic is numerical problems on gas turbine basic cycles. That's a CI engine and SI engine. These are the topics in Unit 1, Fundamentals of Gas Turbine. Next, Unit 2, air breathing engines for aeroplanes. The topics contents in this unit 2 are characteristics of turboprop, turbojet, turbofan, and performance parameters. Thrust, single and twin shaft for turbojet, turboprop, and turbofan engines. Engine design point operations, principles, aerothermodynamic process involved in turbo, ram air engines, and pulse jets in aircraft propulsion. Ideal cycle analysis for turbojet engine, turbofan engine, turboprop engine. See ideal cycle analysis. Next topic is real cycle analysis. Real cycle analysis in the sense actual cycle analysis for the same turbojet, turbofan, and turboprop engine and numerical problems. These are the contents in Unit 2. Next, coming to Unit 3, inlets and compressors. Subsonic inlets, flow characteristics, governing equations of inlets, stall in subsonic inlets. Next, relation between minimum area ratio and external deceleration ratio, comma, diffuser performance. Next, supersonic inlets, inlet guide vanes, characteristics of IGVs. IGV in the sense inlet guide vanes. Next, after complete, these are the topics in inlets. Next, the topics are axial flow compressors. Elementary theory of axial flow compressor, comma, velocity triangles, comma, degree of reaction. Next, flow through an axial flow compressor stage, losses in axial flow compressor stage. The next topic, compressor blade design, losses and blade angle. Multi-stage axial compressor characteristics, HPC, LPC design. HPC means high pressure compressor and LPC means low pressure compressor design. These are the topics. Next, fourth unit, combustion chamber, burner and its performance. The contents are classification of combustion process, important factors affecting combustion chamber design, combustion chamber performance, combustor liner materials and thermal barrier coatings, thermochemistry of combustion, chemical equilibrium, premixed flame and flame stabilization, jet diffusion, flame and droplet combustion, flame propagation, chemical composition of fuels in aviation, biofuels, advanced combustion chemistry, and numerical problems on fuel compositions. Next, burners. Types of burners, materials for combustion chamber, thermal conduction, convection, heating and cooling methodologies, performance sensitivity, flame tube cooling. Next, flame stabilization, use of flame holders, afterburners, ignition methods for GT afterburners. GT means gas turbine afterburners. Next, we enter into Unit 5. Unit 5 is turbines and nozzles. The contents are axial flow turbine introduction, turbine stage. Next, turbine blade 2D cascade analysis, work done, degree of reaction, losses and efficiency. Flow passage, subsonic, transonic and supersonic turbines, multi-staging of turbine. Next topic, turbine cooling, turbine blade design and profiles, aerofoil data and profile construction. The next one is radial turbine. See, above all topics related to axial flow turbines, now these topics are related to radial turbine. Introduction to radial turbine, thermodynamics and aerodynamics of radial turbine characteristics, losses and efficiency. Design of radial turbine, numerical problems. Next, nozzles. Next, these topics are comes under nozzles. Nozzle types, nozzle throat conditions, nozzle efficiency, losses in nozzles, nozzle expansion process, ejector and variable area nozzles, thrust reversal, thrust vectoring, noise reduction methods. These are the topics in unit 5. So the total syllabus has divided into total 5 units: unit 1, unit 2, unit 3, and unit 4, unit 5. So in this course, you are going to learn about all these topics. Thank you very much.